In the last video, I showed you my design for the completion of this challenge, and I started to build it starting with the item class first. I said that a drink and a side dish are both types of items as well as extra toppings for the burger. In this video, I want to pick up where I left off. I want to build out the burger class, which we are saying extends the item class. Let's actually expand the project panel and create a new public class called burger. I'll have this class extend item so it can inherit name and price, and I'll add the 3 additional fields I have for the burger, which I'll call extra 1, extra 2 and extra 3, which will have a type of item. In the next section, you'll learn about things called containers, which are a way to group the same kind of items together. Instead of having 3 attributes like this, I could have a container of extra toppings. I aim to not use any techniques not already taught in the course so far for my solution, so I won't use containers here. Instead, I'll show you how to proceed without those structures. Okay, so those are the burger attributes. I need a constructor now to fix the compilation error. I don't want to include the extras in the constructor, so I'll use the select none button on this pop-up, which will still add code to initialize the superclass. Instead of including extras in the constructor, I'll include a method to add toppings because if you think about it, these are probably going to be something specific for each customer. Firstly, though, I want to change the constructor to remove type as a parameter and instead pass the type burger to the supercall. Now let's override a few methods from the item class. I'll move the cursor outside of the constructor code first. If I don't do that, you won't get the option to override. I'll select the getName and the getAdjustedPrice methods. For burger, let's change the getName method and just include the word burger. This is because the type for the burger will indicate the specific type of burger. Onto the getAdjustedPrice method. I need the price to include the toppings, and I'll start by adjusting it for 1 additional topping first. Return getBasePrice with the following arguments. A ternary operator returning 0 if extra 1 is null, otherwise returning the value from calling extra 1 dot getAdjustedPrice plus. A second ternary operator returning 0 if extra 2 is null, otherwise returning the value from calling extra 2 dot getAdjustedPrice plus. And a third ternary operator for extra 3 with the same rules as the previous 2. Hopefully you're getting really comfortable with the ternary operator by now. As mentioned, I'm using it here in each case to determine if the extra topping is null. If it is, I just return 0, otherwise I'll add the getAdjustedPrice for each extra item. This all gets added to the burger base price, so each extra topping will get added if it has a price. I don't really have a way to test this right now because I don't have any way to add toppings. Let's add a method to add toppings next so we can do that. I'm going to let a string be passed to this method containing the topping to be added, and the code will create the right kind of item based on the value of the string. But I'm also going to need a method to determine the price based on the name of topping that's passed. I'll create that first. Public double get extra price with the parameter of type string called topping name. Return switch using topping name dot to uppercase. Now I'll add a case for the toppings. For avocado or cheese, I'll return 1.0. For bacon, ham or salami, I'll return 1.5. And I'll make the default 0. As you can see, I made avocado and cheese be an extra $1 and these 3 meat types be an extra $1.50. Everything else will have no additional price. Now for the add toppings method, I'll pass the 3 individual string variables as individual parameters, and I'll set up the extra fields by creating a new item for each string passed. Public void add toppings and the 3 parameters of type string, called extra 1, extra 2 and extra 3. We need to create a new item for each extra. This dot extra 1 equals new item with the arguments topping and extra 1. And then the result of calling getExtraPrice passing the value of extra 1 as the argument. Now I'll do exactly the same but for extra 2. And finally for extra 3. With that completed, let's see if I can create a burger, add some toppings and print out its price. First, I'll comment out the other lines in the main method so I can focus on the burger output. Burger equals new burger with regular and 4.00 as arguments. I'll add bacon, cheese and mayo as toppings and print out burger via a call to print item. And if I run that, we get the output, regular burger, $6.50. I started out with a regular burger and I priced that at $4. I then added 3 toppings, bacon, which was an item that I said had the price of $1.50, and cheese was $1. Mayo does not match anything in our get extra price method and is thus priced at 0. Our toppings were a total of $2.50, and add that to the base price, I get $6.50. Okay, so I'm halfway there. Let's add a method to burger that itemises the extra toppings. Public void print itemised list. Print item with the arguments base burger and the result of calling the get base price method. If extra 1 is not null, then call extra 1.print item. Here I first print out the base price of the burger, and then if extra 1 isn't null, I'll print that out via a call to its print item method. I'll copy and paste that and change extra 1 to extra 2. And I'll paste that again and change extra 1 to extra 3 this time. Let's add this to the burger print item method now, so that any time I print a burger, I get an itemised list. I'll override the print item method. And now, I'll just insert the call to print itemised list method first, so the items are printed first. Call print itemised list, print out a heading. And now I can just rerun my code, and I get the toppings itemised for the burger. So that's looking pretty good. It's time now to build the meal using the composition part of this challenge. And I've said we're going to do this in the meal order class. Let's create that class. Now I could have used inheritance here extending the item class, but I've chosen not to. Maybe your design has it extending a base class, and that's a good design too. Now I can add my 3 fields. I'll have burger, which is a burger type, and drink, and side are item types. And now I'll add the constructor. I'll enter this one in manually because I don't want the calling code to pass objects, just strings, describing what the items in the meal are. And I've said I just want a burger type, which will just be regular or deluxe. A drink type, so a Pepsi or Coke maybe, and a side type, which might be fries or potato salad. Public meal order with the 3 parameters I just mentioned. First I'll create the burger by assigning a new burger to our field burger using burger type and 4.0. Next I'll create a new item for the drink and save it to our drink instance field. I'll use drink type and 1.00 as arguments. Finally the side. I'll create the item and save it using side type and $1.50. Confirming what I'm doing here is constructing the meal, that is the parts within this constructor. I create a burger instance and then a drink and side, both item instances. You could have created your constructor to accept the different parts, meaning your parameters could have been a burger or item instead of strings, as I've done here. But I'm doing this so the calling code doesn't have to know about anything except the meal order itself. I'm encapsulating the details of the meal inside this class. I'll create another constructor that has no arguments. I'll just type this above the other constructor. Public meal order. I'll call the 3 parameter constructor, passing regular, Coke and fries as the 3 arguments. With this constructor, the calling code can quickly set up a default meal with a regular burger, medium fries, and medium Coke. Before I try that out, let's write a method that gets the total price of the full meal. Public double get total price. Return side.getAdjustedPrice plus drink.getAdjustedPrice plus burger.getAdjustedPrice. Here, I'm just adding the adjusted prices of the side item, the drink, and the burger, and returning the sum of all 3. But we don't yet have a way to print anything, so let's add a print itemised list method to meal order. Public void print itemised list, burger.printitem, drink.printitem, side.printitem, then a println of a header, and use item.printitem, passing total price as a literal string and the result of calling getTotalPrice. Because everything's really an item, I can call the printItem method on all the parts of the meal. And I can also use that static method on item to include a total price after I print another 30 dashes to separate the total from the itemised list. I'm finally ready to create a meal now with this class. Going back to the main method on the main class, let's comment out the last 3 statements. Then I'll create my first meal, And all I have to do is new meal order without any arguments. Meal order regular meal equals new meal order. Regular meal.print itemized list. And running that, I get the output that looks more like a bill. So we see the regular burger there, that's the burger name, and that's $4. Above that is where we would itemize the burger itself, but right now, this burger has no toppings, so I just see the base burger and its price. And the medium Coke is $1 and medium fries are $1.50. I haven't yet provided a way for the calling code to customize the meal order. I want to let them add toppings and change the drink size. Let's write a method on meal order that lets us add up to 3 toppings. And this really is just a pass-through to the add toppings method on burger. Public void add burger toppings with 3 string parameters. I then invoke burger.addToppings, passing the 3 arguments we received. And let's add a setDrinkSize method on the meal order class. Public void setDrinkSize with a parameter of type string called size. Drink.setSize passing size. Okay, so now I should be able to add some toppings and change the drink size. So let's do that in the main method of the main class. Regular meal.add burger toppings, and I'll use bacon, cheese and mayo again. Regular meal.set drink size, passing large. And let's run that. You can see we have a pretty well formatted bill that includes all the toppings, some of which have additional costs. I started with a regular $4 burger, then add some bacon for $1.50 and cheese for $1, and mayo was no cost. So the total cost of the burger is shown here, and that's $6.50. Okay, so that's pretty good. Let's test out a second meal this time using the constructor with 3 arguments. First, I'll comment out the first meal code. Meal order second meal equals new. Meal order passing 3 strings, turkey, 7-Up, and chili. I'll add 3 toppings, lettuce, cheese and mayo, and set the drink size to small. Finally, I'll print the itemised total. And running this code, I get a turkey burger with a small 7-Up and a medium order of chili. At this point, I've completed the challenge. How did you do? Were you able to create a burger meal that included a hamburger with toppings, a side item and a drink? Did you use composition, inheritance, encapsulation and polymorphism? I hope you enjoyed that. And maybe you took up the bonus challenge to include a different kind of burger with a couple of extra toppings, but a single fixed price for the meal. I'll solve the bonus challenge in the next video. See you there.